Okay, so in this clip we're going to look at recurring decimals. Now there are two types of questions on recurring decimals. The one that comes up least frequently is where they're asking you to turn a fraction into a recurring decimal, and then more often you get questions like this where they're asking you to turn recurring decimals into fractions. Now the GCSE standard of these questions is a question like that, but I thought I'd build up to that with a couple of more straightforward ones first before we take a look at those. But before we move on to those, let's take a look at turning fractions into decimals. Now the method for this is exactly the same as for turning any other fraction into a decimal. So if we took a fraction such as 5/6, for example, if you were asked to turn 5/6 into a decimal, that is, you can think of that another way as 5 divided by 6. Now on a non-calculator paper, 5 divided by 6 you would do using the sort of box method that you would have learned in primary school. But the first thing is, what goes inside, what goes out? Well, what goes inside the box is the number that you're dividing into. 5 divided by 6. So 5 is the number that you were dividing into, and you were dividing it by 6. So if I just go through this process to remind you about a non-calculated division. 6 divides into 5, it doesn't go, so you would put a decimal point and a 0 and add a 0 and then carry over the 5. Then you would say to yourself, how many times does 6 go into 50? You go through your tables. 6 8s are 48, remainder 2. Then you would do 6 into 20, which goes 3 times, remainder 2, and you will see there straight away now that that is going to recur from there. Every time you are going to have a remainder 2, 3, remainder 2. So because that is repeating, it's a recurring decimal, and you can therefore write it as 5/6 is the same as 0.83, and then you put a dot above the repeating fraction. Now these are almost always on non-calculator papers, but just to be sure that we're happy that that is in fact 0.83. If we put the fraction button on and do 5/6 and SD, equals first of all, and then SD, you can see there's 0.83 with a dot above the 3. So that's your method. So we'll try it with these other two. So we got a box. Inside the box goes 5. Outside the box goes 11. So we're saying, how many times does 11 divide into 5? It doesn't. So we add a 0 and carry the 5. How many times does 11 go into 5? Well, 4 11s are 44. So we're going to have a remainder of 6. How many times does 11 go into 60? 5 11s are 55. Remainder 5. And here we can see we're developing this repeating pattern. How many times does 11 go into 50? 4, remainder 6. How many times into 60? 5, remainder 4, and so on. So to write 511 as a recurring decimal, it's the same as 0 point, and then the 4 and the 5 repeat. So you would write that with a dot above each of the repeating figures. So 0.45 with dots above both means 45, 45, 45, 45. Same with this one. So we got our box. Outside the box goes 99. Inside the box goes 12. How many times does 99 go into 12? It doesn't. Add a 0. How many times does 99 go into 120? Well, clearly once, with a remainder of 21. Yeah, to go from 99 to 120, you've got to add 21. How many times does 99 go into 210? Twice. What's the remainder? The remainder is, so 210, the remainder is going to be 11. Hold on. Sorry, no it's not. It's going to be 12. Because you've got two lots of 99, which is 198. You've got to go from 198 to 210. It's 12. So again, here you've got your repeating pattern. How many times does 99 go into 120? Once. What's the remainder? 21, etc., etc., etc. So with this one, 12 over 99 equals 0.12. Both of those digits are repeating, so we put a dot above both. So all you have to do for that is just to practice making up. Doesn't matter if they don't repeat, if they don't recur. What you're practicing is your division method with that, and then use your calculator to check your answer. So that, as I've said, doesn't come up that often, but it does come up. More frequently on the non-calculator paper, you're asked to turn a recurring decimal into a fraction. And it's a technique that you need to learn in order to do that. So I've made these ones up just to practice. So if we start working with 0.4 recurring, what we do is we let x, or any other letter, equal 0.4 recurring. Then we write that out in decimal form. So what that means is 0.444 on forever. So that's the first thing. What we then do is we have to multiply both sides of that equation until we have an entire repeating part on the the right hand side of the decimal point, and a figure on the other side. So rather than 0 point, it'll have a digit there. With ones like this, where it's the first digit and only that digit that recurs, you've only got to multiply by 10. So if you multiply by 10, on this side you get 10x, and on this side, when you multiply it by 10, that means everything shifts left one space, so we get 4.4444 ... What we then do, or what we're then able to do, because these decimal tails are identical, if we subtract those two from each other, the decimal part will all cancel out. So if I call, just like with simultaneous equations, that equation 1, that equation 2, and if I do equation 2 take away equation 1, then I'm going to have 10x take away 1x, which is 9x, equals, and here 4.444444 take away 0.444444 is 4, because all of that part will cancel out. So you get 9x equals 4, x equals 4 over 9. That's the repeating, that's the fraction form of 0.4444. And again, it would be on a non-calculator paper, but just to show you that it is correct, if you do 4 over 9, turn it into a decimal, 0.4, and you can see the dot on top. So if the first number is the repeated digit, and only that digit, then you only have to multiply it by 10 in order to get there. If you take a look at the second one, we're going to let x now equal 0.53, where both of those are occurring. So what that means is we have 0.535353 on forever. Now if we just multiply that by 10, what will happen is that that number will move one place value to the left, and we would have 5.35353. So they wouldn't subtract, because what you would have, if I just put it in here in a different color, that's no use to us, because the decimal part isn't the same. It's not going to cancel out. So this time multiplying by 10 won't help us. Okay, so although I've written that in there, it's no use. So rather than multiply by 10, in order to get the repeating decimal part, I need to have the 5353 back there. So I have to move that number 2 places along the place value columns, which means I have to multiply by 100, not by 10. So this time I've got to multiply by 100, so I get 100x on this side, and on this side then that number is going to move 2 places, so I get 53.535353 and so on. Now when I subtract, I've got 100x take away x, so that works. So 2 take away 1, I'll have 99x, and on this side the 535353 after the decimal point will cancel, and I've just got 53 take away 0, which is 53. So x is 53 over 99. Okay, just to check, fraction button, 53 over 99 equals SD 0.53 dot above both. Now the type that comes up on the exam paper, as we'll see in a moment, is like part C, which is a little bit more complicated again. So I'll just do one of those. Just get myself some paper. So the final example there is 0.324 with dots above the 2 and the 4. So the only repeating digits now are the 2 and the 4. So let's write that whole string of decimals out. 2, 4, 2, 4, 2, 4. Remember, what we're trying to do is to get the repeating part, the only bit on the right hand side of the decimal. So this time I've got to do 2 things. First of all, I'm going to multiply it by 10. To get 3.24242424. So that's my repeating string. And then I've got to have that repeating string again with a different number, because I can't do here 10x take away 1x to get 9x, because I've got a different run of decimals on the right hand side. So I've again got to multiply by an extra power of 10, so by 100, and it's this one now I'm moving, sorry, if I multiply by 100, we do that one in blue, if I multiply that by 100, I get 32.42424 ... So again, multiplying that by 100 doesn't help, because this side, the decimal values are different. They're not matching up. The first digit is a 2 there and a 4 there. So multiplying by 100x doesn't help me. So I'm going to multiply by the next power, which is 1000. So 1000x, that means I move 3 times to the right, to the left of the decimal point. So this one will now become 324.242424. So this one and this one I can subtract. So if I call that one equation 1, that one equation 2, my decimal string, part of it now, is identical. So when I do equation 2, take away equation 1, I get 1000x, take away 10x is 990x. And this side, I got 324, take away 3, which is 321. The decimal strings are aligned, so they will disappear, giving me x is 321 over 990. And just to be sure that we've got that right, 321 990 equals SD 0.3, and then the 2 and the 4 have got the repeating decimals, the repeating dots. So when we have a look now at the past paper questions, every single one of them that has come up has been of that form, where you need to multiply it by 2 different powers of 10s to get the decimals aligned. So here we go. So with this one, we let x equal 0.4787878. We multiply by 10 to get the repeating part. So that would be 4.787878. And then, in order to get the same repeating part again, which is the 7878, we need to move 3 of those across to get to that 787878. So we need to multiply by 1000. So this is what we're multiplying by 1000. So it'll be 478.787878. Call that 1. Call that 2. 2 take away 1. On this side, 990. On this side, all the 0.7878s will go. So we're doing 478 take away 4. 474. So x is 474 over 990. Let's just check it. I know you won't be able to in the exam. 474 over 990 equals 0.478 with dots. You can see here now it's exactly the same for each of the ones to come. So the method is a straightforward one to learn. 0.82322323 times 10, 8.232323, and then to multiply that by 1000 to get to that 232323. equation 1, equation 2, 2 take away 1, 990 on this side, 823 take away 8 on that side, which is 815. So x is 815 over 990. Check. 815, 990, 0.8232323. Same here. Let x equal 0.5414141 and on and on and on, times by 10. Then you need to times it by 1,000 in order to get to the next 41414141. Equation 1, equation 2, 2 take away 1, 990x, the 414141 will disappear. You go 441, take away 5, which is 536. So x is 536 over 990. This one, 434343 is the repeating part, times by 10, 2.434343 repeating. So I need to get to the next 434343, which means I need to multiply by 1,000. Subtract them. 990x on this side, 243 take away 2, 241 left on that side, so x is 241 out of 990. A couple more to do. X equals 0.3464646 and so on, times by 10. Then I need to get to the next 464646, which means I need times by 1,000. Subtract 346, take away 3, so 343 over 990. And the final one, 0.6, two repeating digits, 525252, times by 10, times by 1,000 to get to the next 525252. Two decimal strings are the same. Subtract 990x on this side, and on this side 652, take away 6, 646. So that fraction becomes 646 over 990. So hopefully you can see that's a pretty easy method to learn and practice and get right.